Hey everybody, it's James from RocketBlocks. I'm going to show you what one single session of deliberate practice looks like for people who are preparing for upcoming interviews. So deliberate practice means that you have one specific skill you're trying to improve on, you focus your effort while you're practicing, and when you're done with that effort, you get some kind of actionable feedback on how you did that you can use to improve your own performance over time. Finally, you repeat that practice over time and improve on that skill. To show you what this looks like, I'm going to dive in and show you a few practice sessions of case math, which is just one of the skills top companies are looking for that you can practice on RocketBlocks. So to start, I'm going to choose what skill I want to improve on today. For today, I'm going to focus on some mental math. And just as an introductory sort of skill, I think I'm going to focus on big multiplication, so multiplying a couple of big numbers together. I'm going to do 10 drills at a standard difficulty, and when I'm done, I'm going to show my average benchmark so I can see how I did and think about how to improve. So let's get into it. I'll do this first set using the zeros method and see how I can do for accuracy and time. So using zeros, I'm going to say, for example, there's 4 zeros on the left and 4 zeros on the right. So 8 times 5 is 40, plus the 4 zeros on the left and the 4 zeros on the right. This is 4 billion, quite a large number. 1 times 2 is 2, plus 5 zeros on the left and 3 on the right is 8. That is 200 million. 60,000 times 90,000, that's 6 times 9 is 54, with 4 zeros on the left and 4 on the right. 3,000 times 5,000 is 15, with 3 zeros on the left and 3 on the right. 70,000 times 7,000 is 49, with 4 on the left and 3 on the right. 20,000 times 10,000 is 2, with 4 on the left and 4 on the right. 200,000 times 30,000 is 6, with 5 on the left and 4 on the right. That's 6 billion. 4 and 4 is 16, with 5 on the left and 4 on the right. 16 billion. 8,000 times 9,000 is 72, with 6 zeros. 72 million. 2,000 times 20,000 is 4, with 7 zeros. So that's 40 million. Let's submit our answers and see how we did. Okay, so I got them all right. Notice that I had 100% accuracy, which is pretty good, but I was a little bit slow. So compared to the RocketBlocks average, I was going at 8.7 seconds per problem, whereas the average on RocketBlocks is 7.1. So one thing I can do here is read up on this concept that we have on how to get faster at handling lots of zeros. And I'll summarize this quickly that one thing you can do is think of the unit of 1,000 and the unit of 1,000,000 as two additional numbers to multiply together and to memorize some shortcuts. So for example, 1,000 times 1,000 is 1,000,000, and 1,000 times 1,000,000 is 1,000,000,000. 1,000,000 times 1,000,000 is 1,000,000,000,000. And if you just memorize those, you can do simpler multiplication and add in all of these numbers when you're done. So let's jump back and see if we can do another set and get a little bit faster with our performance. So 4,000 times 3,000, that's 12, and then we know 1,000 times 1,000 is 1,000,000, so it's 12 million. 1,000 times 9,000 is 9 times 1,000 times 1,000, million. 7 times 70 is 490 plus a million. 490 million. 90 times 80, this is a bit of a big one. So 8 times 9 is 72, so that is 720 million. Because you have 1,000 times 1,000 at the end of it. 2,000 times 2,000, that's super easy. That's now 4 million because you know 1,000 times 1,000 is a million. 90,000 times 60,000 is 540 million. Using that same principle. 6,000 times 5,000 is 30 million. 3,000 times 600,000 is 1,800 million, or 1.8 billion. 40,000 times 4,000 is 160 million. There we go. And then 80,000 times 200,000, 80 times 200 is 1,600 million, or 1.6 billion. Let's see how we did this time. Bam. Okay, so we're faster on all of these, but we've dropped in accuracy. So let's see if we can do one more session and improve our overall speed and accuracy at the same time. Before we dive in, let's see if we can learn anything about the mistakes I was making to see if I can improve on this over time. So one thing I noticed is that for each of these mistakes, I was off low by a factor of 10. And when I look back on this, I noticed that I was dropping a 0 in each of my initial multiplications. So 80 times 90 is 7,200, not 720. And 90 times 60 is 5,400, not 540. Same thing where 200 times 80 is 16,000, not 1,600. So this is something I can note, that when my two multiplication bits in the front of the larger numbers each have a 0, I should just be super careful on my zeros in that, so that when I do add back in my 1,000 times 1,000 is a million, I wind up with an accurate number overall. So let's see if we can tie it all together, use the tricks that we've learned from RocketBlocks, as well as what I've learned from my own practice, to see if we can do one session that's quick and accurate. Let's get into it. 3,000 times 100,000 is 300 million. There it is. 9,000 times 9,000 is 81, and 1,000 times 1,000 is a million, so that's 81 million. 7,000 times 6,000 is 42 with a million. Oh, not 62. 70,000 times 9,000, this is 630 million. Like that. Oh, lost a 0. 40,000 times 6,000 is 240 million. 9,000 times 20,000 is 180 million. 10,000 times 6,000 is 60 million. 30,000 times 1,000 is 30 million. 80,000 times 10,000 is 800 million. And 8,000 times 6,000 is 48 million. And let's see how we did this time. Amazing. So using the principles of deliberate practice and some of the tips from RocketBlocks, we're able to improve our accuracy from more than 8 seconds in our first set down to 5.2 seconds per problem. And now we're able to learn from our mistake in the second round and get 100% accuracy using this new method. This is just one way that you can deliberately practice using RocketBlocks to improve yourself on some of the skills that the top companies are looking for. That's all that we've got for today. Thanks for watching. If you enjoyed, be sure to like and subscribe, and have fun casing.